Hi, my name is Lynn White. I'm the Education and Volunteer Specialist for Butler Soil and Water Conservation District, and I'm also one of the project leaders for the Butler County Stream Team, which is a citizen science group that monitors the health of streams here in Butler County. And for many years now, we have gone out and we have sampled the water chemistry, which tells you right there and then if there's something nasty in the river that's going to impact the wildlife that's there. A few years ago, we started doing some trainings for people on biological monitoring because although it's not as accurate as the chemical, it gives us kind of that longer term view of if there's something nasty again washing downstream, some pollution or another, because the different species can be found with different amounts of pollution. They've got different tolerances. This year, we decided to start offering habitat evaluation because it doesn't matter if the water is crystal clear and perfect in every chemical and every chemical way. If there's not habitat there, you're not going to find any of the species. So I did offer a class that was in person, and because of COVID, we couldn't have very many people there. So I'm going to record the training for you now. And at the end of the training, I've got a couple of links that you can follow to try and score habitat yourself, looking at 2 different creeks I recorded. And if you do that, you can then send your score in to me, and we'll see if you reached the about the same score as the people within the class did, and I myself have done. And if you're interested, then you can sign up as one of our volunteers once we were happy with where you're at in scoring things, and you can go out and do this in a stream somewhere here in Butler County. So let me turn my iPad over to the presentation so you don't have to just sit and keep looking at me in my room at home. You can actually watch and see what I'm going to be talking about. So today it's going to be Citizens Qualitative Habitat Evaluation Index. It's a big mouthful for something that's really fun to do, where you actually get out into the creeks and get your feet wet and start poking around, basically, seeing what kind of things there are there that would make fish and other critters happy. So it's a physical look. As I mentioned before, we do the chemical, we've started biological. This is looking at the physical stream characteristics. And so it really does help to get in the water to do this. I know that some of the volunteers that we work with are going to try and do it from the bridges that they already collect chemical samples from. And there's a few stages that will be kind of harder to do. But we want to add this data collected from QHEI to really give us a great understanding of the health of streams here in Butler County, and where we might be able to do some projects in future to help improve the streams for our wildlife. So here's 2 diagrams showing you a couple of different streams. We've got the healthy and the unhealthy, and just glancing at them, you can see some major differences. Our healthy stream has lots of bends in it, lots of meanders in it. And when you have the different shapes and the different bends, that will help with fast moving areas and slow moving areas. Whereas our unhealthy stream there on the right is channelized. Think about the river coming through downtown Hamilton with the levees on the other side. Now, the levees were put there because of the mass flooding that happened back in 1913 and the number of people that lost their lives. So they're there to help protect the surrounding area from flooding, and that is vitally important. Unfortunately, though, being channelized like that, it has taken away the natural bends, those natural meanders, and so it's reduced its value to wildlife. Some of the other differences we see there is the healthy stream has got an area that says riparian vegetation. That's where you've got lots of trees and shrubs and maybe prairie plants growing along the edges that provide habitat to animals, but they can also slow any overland flow, any runoff that's happening, and possibly take some of the pollutants out of that overland flow. For example, if there was erosion going on the farm right next to the creek there, they've got that buffer strip in between, which is riparian vegetation. And the water carrying that soil would meet those plants, and the plants would filter that soil out and slow down that water before it enters the creek. There's a few other bits and pieces there where we have floodplain marked on the healthy. So if there was high flow conditions, the water would be able to break out of the banks without flooding nearby cities like Hamilton. So floodplains are really important. It's important that we protect those areas so we can keep our streams natural and not channelize them. The other thing that makes a healthy stream extremely healthy is that they have areas with pools where the water is deep, and they've got areas where you can see the wiggly lines where the water is moving faster. And then at the bottom, we've got a lot of tree cover where there's shade. Whereas our unhealthy stream, other than tall buildings nearby and an overpass, there's nothing really providing shade there. And there's no buffer between the industry and the farming. It's just right up to the edge of the creek. So anything they're doing on the land there is just going to wash straight into that river, that creek. So there's a quick overview of what's healthy and what's unhealthy. Let's have a look at what we're actually going to do for QHEI. So we're going to look at which areas would be good for it. We're eventually going to try and do this for all of the sampling sites where we get chemical data, but we are more than happy for people to go out in other areas where we don't sample for chemical data. We're restricted on the number of places we can do chemical data because of the cost of the reagents of doing the tests. So we're happy for people to do this anywhere in the county where you legally have access, no trespassing. The datasheet was designed for in wadable streams. That means that we can't go out and do this in a river like the Great Miami. That's not wadable. With the dams and everything in place, that river is far too deep, and we would not be able to use this method on it. Not only because we can't get out there to poke around, but it was not designed for large rivers like the Great Miami River. It was designed for the smaller streams, and the scores are appropriate for those smaller streams that are wadable that you can walk through. So here's part of the paperwork. It didn't all fit in the page and I didn't want to shrink it down. The entire form is available on the Butler County Stream Team website, and I put that across the bottom of the page there. The form's actually two-sided. The second side is where you'll be drawing a diagram of the stretch of river that you're looking at. And it's got a key in the bottom corner to give you some symbols and stuff you can use so it doesn't end up just being words everywhere. But it is a two-sided piece of paper, two-sided form. So what do you need? Well, you need the worksheet, the form. It'd be really hard to go out and score something if you don't know all the questions that are that you have to answer. You'll also need to be able to mark on that worksheet. So you need a pen or a pencil. And because we're hoping you get out into the stream to do this, because that will give you the best results and you'll be able to do all of the scoring sections, then you need to be able to get your feet wet. Don't go in with bare feet. It doesn't matter how great the creek is. There's usually been some idiot around that's throwing a bottle, and there could be broken glass. And even if there's not broken glass, there could be really sharp rocks. So make sure you're wearing appropriate footwear for getting in the water. Whether that's old tennis shoes, rubber boots, waders, whatever. It's a good idea to take your phone with you with the camera to take some pictures. If you fill out the paperwork and submit it with your diagram and some pictures, that means when someone goes to that site in future, they can get a really clear idea of if that site has changed. And creeks are always changing. They're dynamic. If they're not changing, it's because we've channelized them in. So we should expect to see some change. Some streams, you get the change happens much quicker than others. But if you have photos that you can submit as well, that's very, very helpful for future going out, whether it's you or someone else. And then the last thing you need is a 200-foot section of stream that you are going to look at. You can work with a shorter distance, but if you do, your results are not guaranteed to be as accurate, because this was designed for an area that's 200 foot long. And you'll be assessing the whole 200-foot length. I make it sound like 200 foot's a really long way. It's not. But you will be looking at that entire 200-foot length to be able to assess all the different components of the farm. Safety. This is a huge one. If you don't feel safe going to a section to go out and do this, don't do it. Even if it's a site where you've collected chemical data for years, if you don't feel safe there, don't do it. We would rather have you safe than put yourself in a situation. We realize that some of the locations people will have to do the QHEI from a bridge because there's no legal access to get down into the creek. If you are going to do this from a bridge, wear your safety vest. All of our chemical volunteers have got safety vests for out in the field. And if you sign up as a volunteer for this, I'll make sure you get a safety vest as well. But we do prefer people being in creek to do it, but we know that is not always going to be possible. So if you're doing it from a bridge and there is a safety barrier that you can put between you and traffic without falling off the bridge, so like basically at the side of the bridge, put yourself on that opposite side of that safety barrier, just in case somebody's not paying attention when they're driving. The one part that makes it really hard to do this from the bridge is that one of the sections is asking you to kick the riverbed to see how long the water remains cloudy for, and that's not going to be possible from a bridge. So make it really clear on the top of the paperwork that you did your assessment from a bridge and that you had to skip that. So that will impact the score slightly. It'll bring the score down slightly, but it's kind of hard to guesstimate it. But if it looks really identical to some other stream stretches that you actually have been in before, then just mark and say that it was a guesstimate next to it. Trespassing is a huge issue. Please don't do it. For your safety, and also for the safety of our program. If any of our volunteers are caught trespassing, then the EPA does not have to accept any of our data in future for our chemical, even though you're out doing something completely separate, doing QHEI. So no matter what the situation is, if you're going to be crossing someone's property, make sure you have permission. That's why it's a really great idea to get out into some of the parks, to do this in the parks. Because the parks are publicly accessible. Or if you have a creek on your property, or you've a friend that's a landowner that has a creek, you can do it on their property. So this doesn't have to be where we've got our chemical data. Okay, so I mentioned the second side of the paper is for you to draw a site map. We're not talking about you having to be an artist to do this. When I do them, it usually looks like a 2-year-old has drawn on the paper. But you can see kind of a nice one there where they've written in big letters to make it easy to read. And they've used symbols for different things. So they've got the little spikes there for their brushy plants. They marked on there an arrow showing the direction of flow. Then they've got their kind of fluffy cloud shape for the trees. And they've colored in for poles. So if you just use it consistent throughout your diagram, but it's best to do this diagram before you do the front side of the page. Because if you can get down there and walk the 200-foot section while you're drawing this, it will really open your eyes to the questions that are on the front side of the page. Because if you do the front side and then you do your walkthrough for this, you'll realize that you skipped a few things or you got a few things wrong on the front. So do your walkthrough and your site map before doing page 1, like side 1 of the form. So here's side 1 of the form. The first thing it's asking you on there, after asking about the date and the location and so on, just so we've got that record of when and who went out to where, the first question is asking you about the substrate. That's the stuff that is making up the creek bottom. So the sand, the gravel, the boulders, the silt, whatever it happens to be. Now, this is the citizens form, so they've made it very descriptive. The same person that came up with the citizens habitat form also worked on the official form that the Ohio EPA uses when they go out. And they don't have the nice little descriptive, they've got measurements and things on theirs. So I really like the way that they've designed this. But they're asking you, are the rocks mostly large, so larger than your fist? Are they really teeny tiny, like smaller than your fingernail? So it's a very descriptive thing. Now they're asking about your 200-foot stretch. So what is there most of? What makes up the majority of that creek bed? You can select more than one. If it's like a major split, you can select more than one. If you do that, you have to average out the answer. You can't add the points for every single thing. So make sure you average out the answer. The substrate, is it smothered? And is there a whole bunch of like sand and silt that's got down there and it's kind of buried the rocks, so the rocks are hard for you to lift up? And if you do lift them up, are they like black on the bottom because there was no oxygen there, it was anaerobic? Smothering is a big deal because it gets rid of all the little nooks and crannies underneath the rocks where fish like darters can lay eggs, and where some of the food for fish would normally live, things like mayflies and caddisflies and stuff like that. So embeddedness or smothering is not a good thing, and you'll consider your site embedded if greater than 50% of the surface of rocks. So if you look at the rock, if half of it is buried into the sediment. So that is smothering. And then we're going to look at silting. Silting is asking you about kicking the bottom. Being careful not to injure your toes doing this. That's why flip-flops are not a good idea for doing this. But you're going to gently kick the bottom and then stand back and watch to see what happens. Does it get cloudy for more than a minute when you kick the bottom? If there's a bunch of silt on the bottom that's like thicker than an inch, that is really obviously going to affect the aquatic habitat. Again, it will cause problems for nooks and crannies and stuff for the animals to live in. It's different from embeddedness in that it's only considering the really fine materials that will lift up and will cloud the water. So it's not looking to see if the big boulders are embedded in sand and gravel, like the embeddedness one was. So this is only looking at the fine silt, and that's why you're kicking the bottom to see if it clouds up. The second section is looking at the habitat itself. It's looking at fish cover. And so I'm sorry this is like such a small diagrams here, but this is some of the examples that they will give you points for. Now in this section, you're not looking for the one that's the most predominant. You're going to mark all that apply if they're functional. And so if they're functional, like if you look on the bottom left there, they're talking about aquatic vegetation that's emerging from the water. If you see one plant that's emerging from the water, that's not functional. They're talking about, if you look at on the right, that bottom photograph where there's several plants, there's a big clump of plants that are all emerging from the water. That is functional, but one plant standing there on its own is not. So some of the things you'll be looking for are big root wads, so where there's like large trees with large roots overhanging the edge. Shallow areas in slow water, because you can get shallow areas in fast water where the water is tumbling over rocks, but where the water is shallow and moving slow is also important, especially for some of the young fish that are kind of avoiding the larger fish that might eat them. Oxbows or backwaters are kind of those little cut off areas where, like an oxbow is where the river used to flow but the channel moved, and so that's very slow to still water that can provide great habitat. Big boulders. A big boulder that is in fast moving water has got a slow spot behind it, and it's a really great place where fish can kind of swim up and kind of chill for a while. I already mentioned the emergent vegetation. So the next column is the woody debris or logs. Are there a bunch of down trees or a bunch of down shrubs that are in the water? They can provide great habitat for fish, a great cover for the fish, as does the next one, which is undercut banks. And the second picture on the right is showing you an undercut bank. It's dangerous for us to stand on top because we think we're standing on solid ground, but that kind of that erosion that is cut into the bank is usually found around like the deep pools on the outside of a river bend, and it's good cover for fish. Overhanging vegetation, which is the third photograph down, that's also like a nice sheltered area that provides good habitat for fish, and it also provides shading for the fish as well. And then the last diagram that's on there are the root mats. Those are the fine kind of hairy roots that are going in, not the big solid ones, but the finer ones that will make much smaller spaces for the fish to swim through. So it's great for young fish, and also for creatures like dragonfly and damselfly nymphs as well. Third section is looking at the channel itself. So the first part of this is looking at the shape of the channel and how many bends, how many meanders it has in it. And it's nice that it gives a diagram here because it makes it really clear about what they're talking about. So a few weeks ago, I was in Elk Creek up at Sebald Park, which is part of Elk Creek Park, and we were downstream from the entrance bridge. And in that section, we received 0 points because the river is very, very straight in that section. But if you go upstream from the bridge, there's a really good river bend, and then it straightens out again. So if we had done our QHEI upstream of the bridge, we would have received 6 points. But because we were downstream from the bridge and our 200-foot section was very straight, we received 0 points. Now, you can occasionally go, I just can't pick it, it looks like it's between two. If that is the case, don't give yourself points for both of them. Average the points. So I had a few people that were with me that were kind of between whether the river was very straight or mostly straight with some wiggle. But looking at the stream characteristics we were in, it was very straight. But occasionally you can have that bit of doubt. So if we were between 1 to 2 good bends and 2 or more good bends, we weren't quite sure of the count there. Not sure how we wouldn't be sure of the count, but hey, you wouldn't receive 14 points. You wouldn't receive the 6 and the 8, you would only receive 7 points. The next one is looking at how natural the site is. And I've got pictures going down the right there. The first one is a mostly natural site. The second picture, I'm jumping down to point 3. That's got many man-made changes, but it's still got some natural conditions left. So I was standing on the bridge there. This is in the up towards the headwaters of Elk Creek. I was standing on a bridge. Well, there is something that is not natural. And the farmer on one of the sides has, actually kind of on both sides, has removed a lot of the vegetation. The bottom picture there is downtown Hamilton. And that is definitely point 4, heavy man-made changes. The levees that I mentioned before in Hamilton that were built because of the flooding, the river just does not flow naturally there anymore. It is forced to go the shape that the levees are pushing it towards. So that one would receive 0 points on our paperwork. So you can work your way through that. You're also going to look at the area along the riverbanks. You're going to look at the riparian area. The riparian area is the area where there may or may not be woody plants growing. So I'm not talking about like grass, like the bottom picture there in on the right. The bottom picture has got no riparian area. Grass does not count. So we're talking about woody debris. And again, this is a very descriptive one that I kind of like. It's asking you if you can throw a rock through it. So if you chuck a rock and it cannot make its way all the way through the riparian area because it's just too wide for you to throw, not because it hit a tree trunk, but it's too wide for you to throw a rock through it, then that is awesome. That is a wide riparian area. If there are riparian plants, so there are woody plants growing, but you can throw a rock through it, then it's narrow, which is not a lost cause because, as I mentioned before, that bottom picture, no riparian area, that is a lost cause. And it causes problems because if you've got no riparian area, you've got no buffer to anything that might be washing across the land. So if there was sediment getting washed by runoff, by the rainfall towards the creek, if there's a buffer area, if there's a riparian area, those plants can slow that flow of water and they can get that water to drop out some of that sediment it's carrying. Whereas that bottom picture is just going to flow straight in there. The riparian area also helps with erosion of the stream bank itself. As you can see on that bottom one, we've got mass amounts of erosion going on because there's no roots there to help armor the banks. This one, I find it's easier to look at like Google Earth or something like that to assess the land use around your 200-foot section. And I mean, you can kind of eyeball it from the creek, but it's a lot easier looking at aerials for it, and that's why I love using apps like Google Earth and so on to look at the creek. But you're going to select the one that is predominant. So if you're in the middle of a forest area, that's easy. If you're in the middle of an industrial area, that's easy. But if you're looking at the left bank and that's forest, but the right bank is open pasture with cattle, then you can't pick one, obviously. And so again, you would take the two of them and average that answer. So that one, yeah, it is kind of hard sometimes to just pick one. So you may have to average your answer. The Streambank erosion, that first picture, I like to use it because it's such bad erosion. There's your raw collapsing banks. It'd be dangerous to stand on top of those banks because they could cave in underneath you. And they're likely to see more erosion happening if under high flow conditions there. But you're going to be looking at both banks, the left bank and the right bank. And if it's eroding on both, you'll end up with 0 points. Quite often with the natural bends in the river, you can get erosion on one bank and stable banks on the other side. So for this one, quite often number 2 is common, but not always, because you could end up with pristine conditions and you get stable, hard or well-vegetated banks all the way down. Now, when we say stable hard, we're not talking about concrete armoring. That's not going to be providing, that's not going to be great habitat. The concrete armoring was put in there because of rock collapsing banks. So stable and hard is not talking about concrete armoring. But for this, pick one. Either it's collapsing, it's a combination, or it's like great and it's stable. How shaded is a site? The shading is great for the water temperature to keep it constant. If you're in an area like that bottom picture, which I'm using once again, without the shading there and the temperatures in the daytime with all the sun, the temperature of that water can go up, and then at night it can swing back down again. And so you get those wild swings in the water temperature, and that in itself is not good for wildlife. But when water gets warm, it can carry less oxygen, so less dissolved oxygen. Any liquid is going to be able to hold less gas when it's warm. So if you've got a shaded creek, like the top picture there, because most of it is not in full sun, that water temperature is kept constant and it's kept cooler. If you think about glasses of pop, if you've got a warm glass of pop and a cold glass of pop, the warm glass of pop is probably going to be flat. It's not going to have much in the way of gas there. It's not going to have much in the way of carbon dioxide there. But a cold glass of pop, you can usually see all sorts of bubbles in it, and you can feel them when you drink it. So warm liquids will contain less gas. Cool liquids are great because they'll contain more dissolved oxygen for the fish and the other animals that are breathing using gills underwater. So for this one, we want mostly. Quite often we get partly, and hopefully you don't get none, but as you can see, it happens here in the county, happens quite a lot of places. So pick one of them as your answer, either 1, 2, or 3. Okay, for this one, you don't have to do what the guy in the top picture is doing. That is somebody out there with waders on and fly fishing, but you're going to be looking at the depth of the deepest pool. So you might have multiple pools along your 200-foot section of creek, and that's fine. Pick the deepest one. Now, you could, if you felt like getting soaked, go out there and see how deep it is yourself. I have used sticks before, and I've basically thrown rocks before for this when I figured it was more than waist deep, and I didn't really want to get in there. But yeah, I mean, it's very, very simple to tell ankle and knee deep. And if you're walking out and it's getting up to about the level of your shorts and you want to stop, you can tell it's waist deep. So this one, yeah, I don't get in myself if it's waist deep or above. But hey, it's your choice. You're going out to do this on your own. It's your choice. But for this, you'll pick one. But remember, this is the depth of the deepest pool. We're going to be looking at the depth of a different area later on. The flow type is important. Now, for this one, you get to pick multiple answers, and that's because different creatures like different levels of flow. So when I go in and do my stream biology, looking at the macroinvertebrates, the little tiny critters that live underwater, there's some that I know that I'm only going to find in the fast-flowing areas where the water is tumbling over the rocks. And I know if I'm going to go out fishing that I want to look in the deep, slow-moving pools. So there's different flows will be different habitats. So for this, mark all that apply. Now a stream, the way a stream naturally runs, it goes, if we haven't got in there and like channelized it, you should see a riffle area where the water is tumbling over the rocks. And that's where the dissolved oxygen is going to be really high in the water, because that white water you're seeing is that oxygen mixing in there. And as it moves out of that riffle area where the water is tumbling over the rocks, the water's still moving fast. You can see that fast flow, but it's not turbulent anymore. But that's that water slowing as it comes out the riffle, as it goes towards that deep, low flow pool. The water won't stop in the pool. As it comes out of the pool and that water's getting shallower again, the water will start to pick up speed, and that is a glide. And then it will return to a riffle, then a run, a pull, a glide, a riffle, run, pull, glide, and so on. There's a diagram on this next slide. If you look at the profile view up in the top right, you see the riffle at the very top there. Then it goes through that run where the water's still moving fast, but it's getting faster, to that deep pool, to the water coming out of the deep pool, going into the glide, and so on. And there's the plan view. As you can see, we've got how it goes through those different sections. We've got riffle, run, pull, glide, riffle, run, pull, glide. For some reason, my profile view, the water is going from left to right. And in my plan view, the water is going from right to left. So don't let that one fool you. So this time, we're not going to be looking at the depth of the water in the pool. We're going to be looking at the depth of the water in that riffle area where the water is tumbling over the rocks. You're not just going to be looking at the depth of it, you're going to be looking at the speed of it as well. So it's asking you, is it knee deep or deeper and fast? Is it ankle to calf deep and fast? Is it ankle deep or left or less, sorry, and slow? Or there's no riffles or runs, so you can't tell. Be wary if the water is moving very fast to try and do this. You're fine like ankle deep, but if you go much past that and the water's moving really fast, it could pull your feet out from under you. So this is one that I have in the past. I've used a stick and kind of put it out there in the channel to see how deep it is in those areas. Use your judgment on this one and whether or not you think it's going to be safe for you stepping out there. Now, the riffle run areas are where I go into the creek when I'm doing my macroinvertebrate, my biological testing. And so I do get in some of these areas when they're kind of fast, and I do get in these areas when they're knee deep. But there's days I'll go out to a creek that I was in the week before, and I won't get in them again. And it's just that change in flow. So be wary of stepping in there if the water is moving very fast. You can use a stick to tell the depth. This one confuses people because they think this question has been asked before, but this is asking you about the rock size of the riffle run areas. So that fast water that's beginning to slow down going towards the pools. When you were asked the rock size in the very first question, they were talking about the rocks that were all across that 200-foot section. This is focusing on that riffle. So again, they use the same descriptive terms. Is it fist size or larger? Is it larger than your fingernail? And so on. Okay, so you've worked your way through all the questions on the sheet. Now, what do the scores actually mean? Now, with this citizens form, you can actually get a maximum of 114 points. If you get that, send me a lot of pictures, because that one will surprise me if you get a score or anything like that. Because generally a score that is between 70 and 100 is classed as exceptional habitat. When we were out in Elk Creek, I think it was 79 our score is. I need to check the paperwork. But we did score exceptional warm water habitat for there. And there are a few other areas you might get those scores at around the county. But generally, you're going to be finding, hopefully, warm water habitat. You'll have a score either between 50 and 60 or 61 and 69. Unfortunately, in the county, we do have creeks that have been totally channelized, and there's no vegetation, and there's just the water just flows one speed. And so we do sometimes see scores of 0 to 49. But I found when people want to go out and look at a creek, they're not interested in doing those areas anyway. But yeah, that's what the different scores actually mean though. So if you've got between 50 and 60, it can generally be classed as warm water habitat. 61 to 69 it is warm water habitat, and 70 to 100 is exceptional. So if you want to score yourself, I put some really short videos, I think they're about 3 minutes each, on our YouTube channel. So the first link there is to our YouTube channel in general. I put the links on there, but because of the code numbers they put there, it's kind of hard to copy them and get them right. But there is the exact links to the video I did of Indian Creek, and one that I did in Rentschler Forest of a tributary that goes into the Great Miami River. But again, you can find Indian Creek, I think it's Citizens QHEI Indian Creek, and cQHEI Rentschler Forest if you look at our YouTube channel. If you go out, if you want to go out and do it yourself, do both of them and then send the scores to me. On the very bottom there is our email address. That's our general email account. And you can send your score sheets to me from the video. And we'll see if your score matches the score that myself and the people that came to the actual class managed to get. I've also put our website, which is Butler SWCD.org on there. That's for Butler Soil and Water Conservation District. And it provided the website for our volunteer monitoring group, butlercountystreamteam.org. And you can also find us on social media. We're at Butler SWCD. So I hope you have fun and you get to go out and do this yourself. If you have any questions, please feel free to contact me. I'd love to get more people out in the creeks and more people interested in river habitat. Thank you for your time. Bye.